Exactly is given, even same analysis for a capacitor as well. Just have a look at it once. It's the same thing, just as you have drawn for an inductor. Power is VI. Clear?
Yes, sir.
Did you people go through the old rookie questions that I sent you people?
Yes.
Every question is important in that. You cannot afford to miss even one question. Same set of questions are molded this way, that way, and they're asked because the chapter itself is very small. They don't have good number of questions. So the same old rookie questions are put up in different form, old wine in new bottle, and you're given. So every question you have to go through. Do not miss on it. Right? This is a good question asked in one of the test series.
So एक ही साथ पेन किया हुआ ना इसलिए नहीं आ रहा.
Now have a look at this. This is an infinite long current carrying wire. This is an infinite long current carrying wire, I1. And current in this is I2. This is one quadrant of a circle. One quadrant of a circle. This distance is taken as A. This distance is taken as 3A. This is 3. So far, so good? Yes or no?
Yes, sir.
They have asked you, find the force on the quarter of the ring due to the infinite long wire. Find force on quarter of the ring due to the infinite long wire. Will you try or should I discuss?
This is of EMI.
No, not EMI. Magnetism.
Okay.
A force between two current carrying wires. We are playing with the geometry of this. I'll give you one hint in this case. All of you have a look at it. You have a current carrying wire I here. Here I have a current carrying wire I dash. This angle is theta. And this distance is given as dr. You're taking this length to be dr. This is a small element dl. This is a small element dl. Jiska you calculated the, you know the current, you want the force on it. It makes an angle of theta. What do? We will project this on this. This is I dash. This is I dash. Current in this element, and what will dr be? This distance will be dl sine theta. Do you agree with that? Say something.
Yes. Yes, sir.
Right? Now I want the force on this particular element, df. I dash into dl cross this distance is r, right? Only then I can take that to be dr. If this distance is r, that will be dr. R and dr should be in the same direction. Don't forget that. Right? I dash dl r sine theta. Angle between dl and r. Angle between dl and r. dl is this way. Agree? I dash dl sine theta into r. I wrote the formula wrong. None of you people observed.
The df is b.
dl cross b.
Yes.
Right? dl cross mu naught I by 2 pi r. Right? This will be mu naught I dash by 2 pi r dl sine theta. Mu naught I dash by 2 pi r. Dl sine theta will be dr. dl sine theta will be dr.
Sir,
So in the denominator, it would be r plus dr, right?
You know, dr is very small, so obviously r plus dr mein dr is very small.
so but dr you are taking only the horizontal distance, right? But when we move ahead, it will also become a vertical distance.
So bolo,
The r we are considering only the horizontal distance, right? From I. So, but as we go ahead with the semicircle with the quarter thing, so then we'll also have to consider the tangential one, right? Distance.
नहीं, एक मिनट रुक के आराम से देखो. That will not be the case. I'll explain that. 1 second, wait. Carefully observe this at the first place. आधा कॉपी लेने का. Now listen. This is R, this is dr, this is dl. You have taken I into L cross B. Cross product के वजह से you are getting dl sin theta, which will be dr.
Yes, sir.
What we are trying to tell you as an idea is, this is an idea to solve a problem. What is it? This dl's component along R, dl's component along R you take and integrate, you will get the answer. You should take the component of dl along R. Component of dl along R. and you get the answer. DL may have DL cos theta, but that doesn't come in this, right? In the cross product DL cross B may, what will you get? Only DL sin theta aega.
Yes, sir.
B into sin theta. So we are not worried about the cos theta component.
So I'd like you to look at the topmost point of I2 wala part.
Decide first to concentrate on this. I'll come to that. How to use that technique here, I'll explain. First of all, have a look at it. That you're convinced or not.
And so I dash you cannot write as I2.
Pardon?
I dash you cannot write as I2.
क्या पूछ रहे हो? अगर आपको I2 चाहिए, I2 लिख लो. I by chance took I dash. Where do you want to do?
Okay, sir.
I want the same symbols to be used. This are you people convinced?
Yes, sir.
So that means whenever the DL element is not in comfortable terms with I, please resolve it along R. You can use this expression. Even if it is a curved path, when you take a very small length of it, will it become a straight line?
Yes, sir.
Make a note of it. I'll come back to this. I'll have to rub that part of the book. Now, if I were to solve this problem only, when I integrate, I will take from R to whatever is the upper limit of R. From R to the upper limit of R, right?
Yes, sir.
Can I rub the right part of the board?
Yes, sir.
Or even I can keep that on the board and show you this. I will use different colors. Red. This is R. This is R. Do you get that? You have taken a small element R. This is DL. Do you agree with that? DL I took in the direction of I2. DL I took in the direction of I2. This will be DR. This is DL. This is DR. This is I. Do you agree with this?
Yes.
This small length is DL. DR will be along R. Do you agree with that?
Yes, sir.
What is the value of DF? I'm using it from there. Mu naught I1 I2 by 2 pi integral of dr upon r. Integral of dr upon r. I'm using that particular expression. See if you can make a guess that the limits will be from a to 5a.
Yes, sir.
Yes, sir.
Why?
So horizontal distance
And
is A first, and then finally it is the tangential one, hypotenuse.
It's from here till there. Till there means r is shifting this way. This is 3, this is 4. So the hypotenuse is 5. So if we know this formula, any possible shape of this problem, I can be using this. A typically bad problem which has to be solved using this one. Every such type of problem will become bad.
Done, sir.
Can I rub the board? One very tough problem in magnetism. This will take 10-15 minutes. I'll give you no hint. Attempt this. Can I rub the board?
Yes, sir.
Yes.
This is a ring. It is entering into a region with magnetic field. This is a ring moving with a velocity V0. M is the mass of the ring, R is the radius of the ring. Made of an insulating material, carries a uniformly distributed charge. Insulating material carrying charge uniformly distributed. Charge uniformly distributed. Now, quite a few concepts are plugged into this. That's the reason why the problem becomes difficult. I'll read it out, just listen. A ring of mass m and radius r. Mass of the ring is given, radius is given. Made of an insulating material, carries a uniformly distributed charge. The lower surface is smooth. The lower surface is smooth. This is the magnetic field coming perpendicularly out of the board. Initial velocity is V0. Find the charge on the ring so that it starts pure rolling after it completely enters the magnetic field. Find the charge on the ring. Write down the statement. Find the charge on the ring so that it starts pure rolling after it completely enters the magnetic field.
So even afterwards, it is smooth.
All throughout it is smooth. There is no friction anywhere. Did you write down the statement? Find the charge on the ring so that it starts pure rolling after it completely enters the magnetic field.
Sir, I was disconnected. Sir, initially the ring is not rotating, right? It's just moving with the velocity v naught. And then
Initially the ring has only linear velocity v naught. Once it enters the magnetic field, it will be subjected to a force. First hint I'll give you is, initially what was its kinetic energy? Half m v naught square. Finally, what will its kinetic energy be? Half m v square plus half I omega square. Do you agree with that?
Yes.
Half m v square plus half I will be m r square. Omega is v by r whole square. So far, so good.
Yes, sir.
Right? Half gets cancelled out all throughout. Half mv naught square. Half m will go. V naught square is equal to v square plus r square v square. This is 2v square. So when v is equal to v naught by root 2, the body starts rolling. बहुत ही सीधी सा चीज पता है यार तुम्हें, ये तो हमें भी पता है. Now find out, what did he ask you? Charge on the ring for which by the time it enters the ring it will start rolling. That means when did it start rolling? When its velocity became
V naught by root 2.
first hint for it.
So can you check the chat?
नहीं यार. You wrote V naught by 2 BR 1 minus root 2 whole by root 2. No. Second hint. I'll use blue color for the second hint. You have the magnetic field this way. The ring entered by a distance of x. Ring entered by a distance of x. No, I made it at the circle. The ring was red color, right? I take this as theta and this as theta. This distance is x. Are you able to see the x value? X is the distance the ring moved into this particular magnetic field. X is the distance the ring moved into this particular magnetic field. The ring is moving with a velocity v. So dx by dt will be v. Remember that and keep that in your mind. Right? Now you will consider, not same color, let's take green. You will consider an element such that this angle is phi, this angle is d phi. This element will have a velocity of r omega this way and v this way. Velocity of that point with respect to center of mass plus velocity of center of mass with respect to the ground will be the resultant velocity of that particular point. And this will have omega in this direction.
So what happened to V naught?
What happened to?
V naught.
V naught तो change होगा ना यार as it is entered inside. V naught same रहेगा तो rolling कैसा रही होगा? The rolling happens when V becomes V naught by root 2. As it enters inside, there will be a force and a torque on it. So omega will keep increasing, velocity will keep decreasing. At some state, V equal to R omega should be reached. Only then the body will roll. The ring is not in air, it is on the ground. I have drawn the free body diagram. This is the second hint. Think carefully and proceed. It's a long problem and a tough one. Which doesn't make much difference for you, but I'll calculate dq. I'll calculate dq. dq here will be charge per unit area 2 pi r into r d phi. So this will be charge by 2 pi into d phi will be dq. dq is the charge on this small element. Now find the force on the small element. I'll give you one hint. थोड़ा ध्यान से देखिए. You already know that when the linear velocity reaches v naught by root 2, the ring will start rolling. Yes or no? Right? So if you can calculate the velocity, rather the distance moved, by the time x becomes equal to 2r. When will x become equal to 2r? When theta goes from 0 to pi?
Yes.
By the time the ring completely enters the magnetic field, what should its linear velocity become?
V naught value.
That's the hint. Now try the problem. By the time the ring completely enters the magnetic field, ring completely entering the magnetic field means x should be 2r or theta should be pi. At that instant, velocity of the ring should become v naught by 2r. Shall I go one more step ahead?
No, sir. Just a second.
One more hint I'll give you so that you go one more step ahead. Have a look at it. What are you in search of? Velocity along x-axis from V0 should reach V0 by root 2. This is what you're searching for?
Yes.
That means I should get the acceleration along x-axis rather force along x-axis.
Yes, sir.
Do you think this velocity component will give me any force along the x-axis? V cross B, it will give me this velocity all throughout the ring will be only along the negative y-axis. V cross B, V is along x-axis, magnetic field is along this axis. V cross B will be in which direction? Downward direction?
Yes, sir.
Yes or no?
Yes, sir.
So this V cross B all throughout the problem doesn't affect your horizontal force. And what affects my horizontal force? Yes or no?
Yes, sir.
I repeat, where did we start our problem? Don't lose a track of the problem. Problem is long, slightly difficult. You are in search of a situation when the complete ring enters the magnetic field. By the time it enters the magnetic field, its velocity should become V naught by root 2. This velocity is along which direction? X-axis?
Yes, sir.
So this velocity, if I want to calculate, I should calculate the acceleration in that direction, rather force in that direction. V component of the ring does not give me any force along the x-axis. This component will give me force along the negative y-axis. This is V, this is B. V cross B is in which direction?
Downward.
So I will not touch this aspect of V. I am only interested in R omega now. Find out the force on that small element due to R omega and resolve that force along which direction?
Horizontal.
Now, did I give you a way to go ahead?
Sir, but because the force is acting downward, so it won't affect omega.
Not interested in omega. मैंने eliminate कर दिया फिर omega क्यों जाऊंगा?
Because R omega will be dependent on omega. And if force is acting downward, so omega.
Use that up. I already used that up. Omega से मुझे कुछ लेना देना ही नहीं अभी. Omega फिर then you keep it in terms of omega. Convert V in terms of omega. My simple condition is by the time velocity of center of mass becomes V naught by root 2, the ring should completely enter the magnetic field. It will be by default be rolling. Don't bring omega inside. With great difficulty, I eliminated omega. I put omega is V by R. Now again you bring omega, you'll have two variables.
Got it.
So can you check the chat?
I thought I'll rub the left part of the board so that I can continue with the problem. Tell me if I can rub the left part of the board.
Yes.
Somebody asked me to wait in between. I'll rub the left part of the board. Wonderful. This one job is easy here. There at my home, I have 3 dusters and 2 cloths. Sometimes the duster need to be cleaned. The duster I don't clean, so rubbing is very difficult. Here erasing is quite easy.
Sir, can you check the chat?
MV by 4BRQ. No, no. Now listen. DF due to R omega component. I am not going to calculate DF due to V. Why I already explained to you. DF due to R omega. DF due to R omega. F, V, I. Have a look at it. V is towards you people. I is R omega. Force will be, DF will be due to R omega towards the center. This will be the direction of DF. Due to R omega, DF will be in this direction. Are you convinced?
Yes, sir.
So what will its horizontal component be? My requirement is DF cos phi. Do you agree with this?
Yes.
Its horizontal component should be, this black line is a mistake. I rub this, whole of that will get disturbed.
Sir, you can undo.
So you can undo.
Undo कहाँ पर करूँ?
The right में है.
This arrow?
Yes, sir.
Oh, wonderful. Thank you. Right. DF due to R omega will be in this direction. This DF ka horizontal component is DF cos phi, which I will write it as Fx. Fx is equal to M dVx by dt. This I will write as M Vx dVx by dx. Am I right? So far, so good. Yes or no?
Yes,
Yes,
sir.
sir.
B dq r omega. Df will be this. Now my requirement is df cos theta. B dq already I calculated. I should have. Right. B dq will be q d phi by 2 pi. dq I substituted from there. R omega cos phi is equal to m vx dvx by dx. Till here, are we clear?
Yes, sir.
First of all, I should calculate fx before going for m dvx by vx. Wait, I'll have to calculate fx first. df cos phi from 0 to theta. fx, right? I will rub this part of it. क्या करना हूँ? This is fx. This is fx. Agreed? B capital Q d phi. Hope I have got it right. Perfect. By 2 pi integral d phi. Now this fx technically df cos phi. Fx is df cos phi. Least value of phi is 0. Maximum value of phi is theta. So first I'll get the expression for fx. Fx is d q r omega by 2 pi integral of cos phi d phi 0 to theta. 0 to theta. How much are you getting this to be? D Q R omega by 2 pi. This will be minus integral, not minus, y sine theta minus sine 0. This is along I cap. Is my simplification correct till here?
Yes, sir.
One mistake. See, phi ka least value is minus theta to theta. This is technically minus theta to theta. This is minus theta to theta.
फिर तो 0 हो जाएगा सर.
Then I will just remove this. Minus theta to theta will become 2 times 0 to theta. Minus theta to theta will become 2 times 0 to theta. So I remove the 2 in the denominator. This is my fx. Why are you in search of fx here? Why are you in search of fx? Because I need the linear velocity. Now f cos theta is in this direction. From v naught, it should come down to v naught by root 2. Right? Till here, is it clear? df due to r omega. You didn't take df due to v because that will always be in the downward direction. Due to r omega you have taken. And incidentally, this will not change the omega value there. df is passing through the center of mass of the ring. So what changes the omega value will be these factors. df due to r omega will not change the omega.
So I'm still having confusion that you told that omega will change due to the factor of v because it's
Right.
acting downwards, but still why we are not considering it?
We are considering it. We converted omega in terms of v. We have considered omega. Only thing, at this particular instant, here you have got omega out of the integral. Suppose you want to solve the problem in terms of omega instead of v. We can comfortably do it. Absolutely no issue.
The doubt is not in terms of omega, but isn't that it won't be a constant, right? Omega is changing continuously.
It has to change. From initially its value is 0. It will reach a particular value of omega. Omega is v by r.
So how can you bring it out of the integral?
Theta, you are taking it at this particular instant when the angle is theta. Here you are integrating with respect to that angle theta, that length it has gone inside. So you are dealing with at that particular instant fx.
Can you tell the blue step? How did you reach there? Fourth step.
1, 2, 3, 4. See this value dq I substituted from there. dq I substituted from there. Right? And I took df cos phi.
Right.
That is fx. Now you know the expression for fx as a function of theta. You know the expression for fx as a function of theta. Right? Yes or no?
Yes, sir.
fx you will write as what? M vx dvx by dx.
Yes, sir.
I need to rub the left part of this to use that. I'll replace fx with this particular value, rather this value, mvx dvx by dx.
So the direction of f of fx would be minus I, right? Minus I cap.
Minus I cap, you're right, minus I cap. I should put a minus. Technically, it is minus I cap because this is df, this is df cos phi. I'll keep this as it is and I'll rub this part of the board. Right? Please take it down till here. I'll rub this part of the board and I'll use this in front of it. This part I will rub. Tell me when I can do it. Next 2 steps में answer आ जाएगा.
Done, sir.
Right? Now this is fx. Do you agree with that?
Yes.
This is equal to fx. Do you agree with that? So I will write this fx here. M vx dvx by dx is equal to b q r omega by pi sin theta minus I cap. Happy? Say something.
Yes, sir.
Next 2 steps is the answer. How do you manage that? I'll give you 2 minutes to think on it. एक क्लास के बाद थोड़ा आदत पड़ जाती है. One hint I'll give you as to how to eliminate dx. Have a look at this. X is equal to, this distance was x, right? R minus R cos theta. Do you agree with that? This distance was x. X is equal to R minus R cos theta. Do you agree with that?
Yes, sir.
Dx is equal to R into 0 minus of sin theta d theta. So dx का elimination in terms of sin theta d theta आ गया कि नहीं? R sin theta d theta. I will write dx is equal to R sin theta d theta. Say something. One variable I know how to play with now. So m vx dvx is equal to b q r omega by pi. Dx I'm bringing it to the numerator. This will become sine square theta d theta. Do you agree with this?
Yes.
This is a smart move, right? If not, you would be struggling with three variables, theta, x and vx. You eliminated dx in one go. X is equal to r minus r cos theta. Dx is r sin theta d theta. How many concepts they used in one single problem you see? I'll give you one more minute. Next step, you should be getting your answer.
So dvx should be negative, right? Because vx is decreasing.
Negative, yeah, that right hand side negative I forgot to carry. Q B sine square theta. I will skip one step and write the next step here. Vx dvx upon root over of v naught square minus vx square will be equal to, obviously with a negative sign, qbr by pi m integral sine square theta d theta. Theta should go from 0 to pi. Velocity should go from v naught to v naught by root 2. This will give me the answer, but you will have to figure out how I came from this step to this step. R sine square theta is not a big deal. Pi m I brought to the denominator, but how did I write this part of omega as root over of v naught square minus vx square and bring it to the denominator? Do you know this integration?
Yes, sir.
Right? Now just figure out how I got this. That completes the problem. Figure out how I got this. You'll tell me.
Sir, you got it from the energy equation. Kinetic energy.
Could you tell me how?
The half mvx squared will be equal to half mv naught squared plus.
Awesome. Kinetic energy equation फिर से लिखो यहाँ. You're able to see the board. Half m v naught square is equal to half m v square plus half m r square omega square. Right? Half will go, m will go. V naught square is v square plus r square omega square. V naught square minus v square by r square is omega square. That's what I substituted here. Step by step, if you observe, somewhere down the lane when you're solving the problem, you lose the track of where you are. इतना लंबा है problem. Right? and nothing is beyond your scope. Everything is reachable. Only thing, the problem is so long that we lose a track of where we are standing.
So next class you're starting offline.
Pardon?
You are starting offline from next class.
अरे नहीं, पहले ये तो एस्टैब्लिश होने दो. ऑफलाइन के लिए इस रूम में 1 2 3 4 5 6 7 8 9. The room in which I am taking the class have 9 benches. So
So only 9 students.
Otherwise, with you people, we are pretty safe. The syllabus is almost over. Tomorrow will be, today evening, I have a doubt lecture with NAPJC, old APJC 1-2. I'll be taking magnetism booklet doubt 7 to 9. Will you people also join? Or do you have another doubt lecture?
We don't have any other lecture.
7 to 9, shall I send you the link?
Yes, sir.
Which exercise?
Exercise 4, exercise 3 of magnetism booklet.
So 1 2 is done.
Yes, sir.
Exercise
1 and 2 is over.
1 and 2 is over. 1 and 2 आप लोगों के साथ ही किया था ना यार मैंने.
हाँ सर.
तो 3 and 4 उनके साथ डिस्कस कर रहा हूँ. So then tomorrow what do we do?
EMI.
EMI, are you people done? Can we finish HCV tomorrow?
No.
What do we do? एक बच्चे ने टाइप किया yes sir HCV done. आज रात को खत्म कर दो HCV. होगा? सब चुप है.
सर वोटिंग ले लीजिए.
Tomorrow वोटिंग के लिए लोग सो रहे हो, जागो. सुनो, tomorrow can I take HCV doubts of EMI? People who are okay with it, raise your hands. Tomorrow can I take HCV doubts of EMI in your class? People are okay with it, raise your hands. No बच्चे हाथ उठाए यार. So tomorrow what do you want me to do then? Vernier caliper, screw gauge. Speak.
Yes sir, वही करते हैं.
We'll go ahead with vernier caliper, screw gauge, and शायरी. Class cancel कर दूंगा, बैठ के शायरी सुनाए. And 3 block system. Okay, please catch up quickly. Arshit says half of HCV. Hey, that's also a good idea. First 62 problems of HCV discuss कर सकते. EMI HCV first 62. Objectives. कितने सारे objectives है भाई साहब? कब खत्म करोगे? EMI is an important chapter. कब खत्म करोगे? जल्दी खत्म करो. अब ऐसे डिले करते रहोगे तो क्लासेस शिफ्ट हो जाएंगे and I will not have time with you people to clear the doubts. Please catch up quickly. Right? EMI कम से कम HCV तो खत्म करो. Tomorrow at least some part of HCV खत्म करके first objectives लूंगा, फिर first 50 problems of HCV लूंगा, उसके बाद I'll go for vernier caliper and screw gauge. Tomorrow's class. Try to finish HCV as much as possible. जहां तक खत्म किया वहां तक तो doubts clear कर दूंगा.
Okay.
Chalo, see you people in tomorrow's class. Good day. Bye. And thank you.
Thank you, sir.